answer, the quotient for this problem, is x squared minus 5x plus 6. Hopefully you're getting the idea of polynomial long division and or CPM method. They both work 100% of the time, so you get to pick which one you like, and you can go with that one. You must learn one or the other. So there's a third way to divide polynomials, and that's using the synthetic substitution process that we learned last week. It turns out that if you would take example 1, so let's go back and see what example 1 was. So example 1, we had x cubed plus 5x squared minus 7x plus 2, and we're dividing by x minus 2. So again, that was x cubed plus 5x squared minus 7x plus 2. And we're dividing it by x minus 2. Well, if we take this function and evaluate it for x equals 2, we're going to see that f of 2 gives us the remainder for that division problem. So we set it up for synthetic. So my leading coefficient was a 1, my next coefficient was 5, then it was negative 7, then it was 2. Since I'm evaluating for 2, I put a 2 on the outside. I bring the first number straight down. I multiply the 1 times the 2. I add straight down. I multiply the 7 times the 2. I add straight down. I multiply the 7 times the 2. I add straight down. So my solution is 16, which once again, if we go back here to example 1, yep, that was our remainder. The other coefficients turn out to be the coefficients for the rest of the polynomial as well. This is my constant. This is my linear term. This is my x squared term. So that I see that the quotient was 1x squared plus 7x plus 7 plus 16 over x minus 2, which is exactly what we got when we solved this polynomial with the CPM method and with polynomial long division. So synthetic division is another option, but it only works when you're dividing by linear divisors. So it has to be x plus or minus some number. It doesn't work if you have an x squared or x cubed or anything else. Again, it has to be x plus or minus some constant value. So the remainder theorem states if a polynomial f of x is divided by x minus k, then the remainder r is equal to f of k. Whatever that final number is when we perform synthetic substitution or synthetic division, that's our remainder. We would count up from the right then. The remainder is the last one, the second to last is your constant, the next one will be your linear, your quadratic, and so on. So let's use synthetic division to divide these two polynomials. We can do it because the second polynomial is linear. It's x plus 3. To figure out what to evaluate it for, we always take what we're dividing by and set it equal to 0, solve, and see that we should evaluate for negative 3. Negative 3 is going to be the 0 of that function. So I bring in my leading coefficients, 2, 1, negative 8, and 5. I bring the first one straight down. I multiply. I add. Multiply. Add. Multiply. Add. So, here's my remainder. Here's my constant. Here's the linear term. Here's the quadratic term. So my answer is 2x squared minus 5x plus 7 minus 16 over x plus 3. There's my quotient. The factor theorem states a polynomial f of x has a factor x minus k if and only if f of k equals 0. meaning your remainder is 0. So we're going to use this idea in synthetic division to factor polynomials completely. This is why we're learning polynomial division, so that we can solve any polynomial given to us. So in problem 5, they're asking us to factor this polynomial, given that this is one of the factors. So what we know is that f of x equals 3x cubed minus 4x squared minus 28x minus 16 is equal to x plus 2 times some other factors. What we got to figure out are, what are those other factors? This has 4 terms, so if we try and use our factoring strategies, we'd attempt to factor by grouping. So if we group the first 2 terms and the second 2 terms, when we think about taking out their GCF, well, for the first binomial it'd be x squared, leaving us with 3x minus 4. For the second one it'd be negative 4, leaving us with 7x plus 4. The problem is that these aren't the same, and they're not even really that close to being the same. So factor by grouping just isn't going to work. We need another strategy. That's why we're learning how to divide polynomials. So I'm going to use synthetic division. If x plus 2 is a factor, well, that tells me that negative 2 is the 0. So if I do synthetic division for negative 2, I should get my other factors. So I put the negative 2 on the outside. I put in my leading coefficients, 3, negative 4, negative 28, negative 16. Bring down your first term, multiply it by the negative 2, add straight down, multiply, add straight down, multiply, add straight down. Remainder of 0 is good. It means we're on the right track because they told us this is a factor. And if x plus 2 is really a factor, it means it would divide evenly and have no remainder. So this is my constant. This is my linear term. This is my quadratic term. So my other factor is x squared, 3x squared, plus a negative 10x. Minus 8. And now I have to factor that. So I keep my first factor. I'm going to factor down the second one. 3 is prime, so I know it has to be 3x times x. I need to multiply to negative 8, but have my outsides and insides combined to negative 10. Well, if I put negative 4 for the outsides, I'll get negative 12x, and then I can put my positive 2 in the inside, so that negative 12 plus 2 gives me the negative 10x. There's my complete factorization. I now know that my my cubic function, 3x cubed minus 4x squared minus 28x minus 16, factored into the product of 3 binomials, x plus 2, 3x plus 2, and x minus 4. So we can use polynomial division to completely factor any given polynomial. Right now we have to give you a starting factor, and we're going to do it with synthetic division. So take that starting factor, set it equal to 0 to solve, use synthetic division to get the other factor, factor that down, and you'll have your complete factorization. Check out part 3 of the video for the conclusion of these notes. Again, I apologize for all of the background noise, difficult to achieve silence for the 16-month-old and a dog. I hope you were able to understand and get something out of this.